Bismillahirrahmanirrahim. This is a short video for process analysis. So, in most of the cases, you will also need to analyze the processes because the cycle time of the system and production rate of the system depends on the processes. ये bottleneck station जो आप identify करते हैं, so that is basically the processing time of any activity. In process analysis, we normally study and analyze the activities that happens within the system. So let me start the presentation. So process is any activity within the system. Specifically, जब आप मैन्युफैक्चरिंग सिस्टम की बात करते हैं तो process is an activity which transforms a material from one form to another form. So technically अगर आप इसको define करना चाहें जो book definition जिसे आप कहते हैं तो process is a series of independent tasks that transforms an input into output material with some value added. For example, Toyota transforms steel, rubber, and plastic into cars. For process analysis, a question may arise that why do you need to analyze the process? So this is because we have to identify the inefficient tasks. We study the processes that will be performed for the production of any good, and then we try to distribute those tasks, distribute those processes as evenly as possible among the workstations so that we can reduce the waiting times within the system. And when you are reducing the waiting times, so you are basically increasing the efficiency of the system, which is the production rate, or you can say the throughput rate of the system. So you have to identify the inefficient tasks and then to spot the possible effectiveness improvement tasks. कि ये जो जहाँ पे inefficiencies हैं, जहाँ पे waitings बहुत ज़्यादा आ रही है, how we can decrease them, how effectively we will perform those processes with limited number of machines as possible. And then finally to understand where the value can be added. वैल्यू जो है उस वक्त आप ऐड करेंगे जब आप जो साइकिल टाइम है वो आप कम से कम जो है वो डिज़ाइन करेंगे एक सिस्टम के लिए. एंड जितना आपका साइकिल टाइम कम होगा उतनी आपकी प्रोडक्शन रेट जो है वो ज़्यादा होगी. How will you analyze the process? Basically, you will look into the performance measures regarding these processes. And the performance measures are the machining times, the loading and unloading times, the waiting times, the transportation times. ये सब मिलके आप cycle time calculate करते हैं and then you go for the throughput time and then the production rate or throughput rate of the system. Processes are normally जब आप उसको यानी analyze करते हैं तो we represent those activities in graphical representation. और graphical representation में जो symbols use होते हैं that must be understand first before going to the analysis. So graphical description of a process normally consists of these four major entities which are bulleted here in red. The first one is the holding. Holding जो है they are represented graphically by inverted triangle, and they may represent the raw materials or the work in process within the system, or it may represent a finished good inventory, normally abbreviated as FGI. सो एफ जी आई जो है वो आपका फाइनल प्रोडक्ट होगा। अगर कम्प्लीटली रा फॉर्म में है आपका मटेरियल, सो दैट विल बी रा मटेरियल, एंड इफ इट इज़ going through some processes, so it will be considered as the work in process. So these holdings are basically the storage facilities that are provided within the system. ये buffer zone भी हो सकता है, ये main storage facility भी हो सकती है, and it can be some waiting area for the work pieces to wait or to reside for the upcoming processes. Next symbol that we used is for the sequence, and the sequence basically is the direction of the raw material or the workpiece, or you can say the work in process, which it will follow. And then are normally represented by arrows. And then the actual step that you need to define graphically is the processing step. Processing step is basically the workstation within the system. So it can be any process, and processes are normally represented through rectangles. So wherever you see a rectangle symbol within the graphical model of a manufacturing system, so it will be referring to some processing activity. And then you have a decision point, and decision point is normally located at the end of the processing step or at the end of the holding symbol. And for example, if you have multiple paths available for the workpiece to follow, so then you have to take decision that which path will be followed by the workpiece after a processing step. So these are the graphical representations of the process flow charts. So it is a flow chart, a process flow chart, which shows a system. Two systems हैं आपके पास. For example, we have two workstations within a system, and the workpiece is processed in the sequence represented by the arrows. So टास्क वन जो है वो फर्स्ट मशीन पे होगा, फिर टास्क टू होगा, और आखिर में जो एफ जी आई की या होल्डिंग की सिंबल आपको नज़र आ रही है, so it represents the finished good inventories. So these graphical representations are normally uh, available at the entrance of a manufacturing system. शायद आपने कभी गौर किया हो या नहीं किया हो, but normally they represents the two policies that we discussed earlier. और वो टू मेन पॉलिसीज़ जो थी वो थी मेक टू ऑर्डर और मेक टू स्टॉक की फ़िलासफ़ी. सो अगर आपके पास एक मैन्युफैक्चरिंग सेटअप है, सो वो इन दोनों में से किसी एक फ़िलासफ़ी के तहत जो है वो वर्क कर रही होगी. आइदर इट विल बी ए प्रोडक्शन टू stock setup, or it may be production to order setup. So if the symbol is like this, so it represents the make to stock, or you can say production to stock philosophy. When the demand is put by a customer, so the finished good inventory is available, and simply the system will deliver the products to the market, or you can say to the customer. And this symbol represent the make to order philosophy. You will have to perform the tasks whenever an order is received by the company. So these are the two international standard normally used by the factories to call themselves as make to stock setups or make to order setups. प्रोसेस एनालिसिस की जब आप बात करते हैं, एंड देन वी डिस्कस दैट बाय प्रोसेस एनालिसिस वी मीन टू analyze the performance measures. So what are those performance measures? We will discuss them. So, for example, if we have a system in which there are multiple tasks as represented here graphically, so let us assume a process in place. So, what you will need to measure in order to understand that how efficient this system is. For this, you will look for one of the major performance measures, which will be the capacity of the system. That what is capacity of this particular system? And capacity is basically the production rate or the throughput rate. Capacity means that how many units will be produced per unit time, and that unit time may be a day, it may be a week, a month, or a year. So that will depend upon the philosophy of the production setup. So, what will be the capacity of the system? That is how many units per unit time will go through each task. Uh, so, you have to come up with a figure that will be associated as a whole to that particular system. So you will need to define or come up with the production capacity or the production rate of the whole system, and that production rate of the whole system will depend on the individual activities. Uh, why it will depend on that individual activity? This is because the, the capacity or the production rate of the system will depend on the slowest workstation of the system. और ये हम डिस्कस कर चुके हैं कि स्लोएस्ट वर्क स्टेशन जो होता है उसको हम बॉटलनेक स्टेशन कहते हैं. सो यू विल फर्स्ट फाइंड द बॉटलनेक वर्क स्टेशन. Bottleneck station is the busiest workstation, or you can say the, the, the station which will have the largest cycle time. Cycle time means machining time. Or inversely, you can say that the slowest workstation will be the bottleneck. So जिसका टास्क टाइम सबसे ज़्यादा होगा, ज़ाहिर है वो आपका स्लोएस्ट वर्क स्टेशन ही होगा, या आप कह सकते हैं कि ये बिजिएस्ट वर्क स्टेशन है. Anyhow, the station having the maximum of the cycle time will be the bottleneck station, and the capacity will be totally dependent on that bottleneck. So you have to identify which production step will limit the process capacity. And third one is then the throughput time. Throughput time is the total time that a particular workpiece will spend within the system. For example, अगर इसका let us say task 1, task 2, task 3 सबका time जो है वो 10 minutes है. So in total the workpiece will spend 30 minutes time within this system. But that 30-minute time is the throughput time, and the cycle time will be the performance measure, not the throughput time. थ्रूपुट टाइम जो है वो हमें फिर चाहिए होगा वर्क इन प्रोसेस को कैलकुलेट करने के लिए. सो इट इज़ वन ऑफ द परफॉर्मेंस मेजर्स, बट द मेन परफॉर्मेंस मेजर दैट यू विल be very careful about is the capacity and the bottleneck station. So capacity की जब आप बात करते हैं तो how do you measure the capacity? So capacity, as I said, that capacity of a task is the physical limitation in terms of the production rate, that how much units will be processed in some specific time unit. So cycle time जो है normally आपका बन जाता है जो average time एक system का जिसमें एक complete product जो है वो आपका complete होगा system के through. So cycle time is the average time for completion of one unit, a production step or a process, and it normally do not include the waiting time. And normally cycle time will be measured as time per unit. At 5 minutes per unit है या 10 minutes per unit है. and throughput rate or production rate is inverse of the cycle time. So इसका जो time unit है, that is units per time. That how many units will be produced per unit time. Unit time जो भी होगा normally हम hours में calculate करते हैं, और cycle time जो है normally it will be given in minutes or second. So throughput rate is 1 by cycle time, or this throughput rate is basically the capacity of the system. So this means that अगर आपके पास cycle time आ गया है तो you can calculate the capacity of the system. And capacity of the system is a throughput rate, or you can say the production rate. How you will find the cycle times, जो previous videos हैं उसमें standard formulation हमने use की थी line balancing techniques में. For processes, the same methodology is used, but another entity is associated with a process जो कि setup time जिसे हम कहते हैं. So every machine, every workstation needs some setup time before the start of the production. So if that setup time is given in the problem, you will have to add that to the cycle time. और cycle time normally जब आप calculate करते हैं, so that is basically the total number of units multiplied by the time of each unit. यानी for example अगर आपके पास आपने 10 products बनाने हैं and one product is suppose completed in 5 minutes, so in total you will need 50 minutes. 10 into 5, 50 minutes, and if you divide it by that particular batch size, so you will get the average cycle time of the system. 50 into 10 divided by 50, या 50 into 5 divided by 50, तो वो आपका exactly 5 minutes per unit आ जाएगा. So it is simple. Cycle time is normally calculated as the total batch size into time divided by that particular batch size. So it is the average cycle time. And if the setup time is given, so you will have to add that also to the formula. So for example, if there is a company who is producing 100 cars and on average the production takes let us say 5 hours to complete a car, to completely assemble a car, and suppose it takes 50 hours to set up the production line. So this 50 hours is the setup time. So for this particular system, when you will calculate the cycle time, so you need to address this setup time also. So you have to add it with the basic cycle time formula. So it will be setup time plus batch size into time per unit divided by batch size. So it will be the average time of the cycle for that particular system. Suppose we have an activity within a system from point A to B. Suppose there are two holding places, and in between those two holding places we have an activity, and suppose the production time of this activity is 25 minutes per unit. ठीक है ना. So इस स्टेशन का प्रोडक्शन टाइम जो है वो 25 मिनट पर यूनिट है. Let me so what will be the cycle time between point A and B of this particular process? Suppose we have to work in batches of 10. So batch size is 10. Production time of each unit is 25 minutes per unit, and then the setup time is 15. So simply by using this formula, you will have to add that particular setup time when you will find the cycle time of this workstation time. So workstation time इसका या cycle time this particular process का it will be 15 plus 25 into 10, which is the batch size, and divided by 25, divided by 10, will give you the actual cycle time of this particular activity. And then you will also have to find the bottleneck station. If a system is given graphically, so first you will find the cycle time of each workstation independently, and then among them you will find the bottleneck. So suppose we have three activities और उनका cycle time जो है वो आपने निकाल दिया है. And suppose the cycle time of this station is 3 units per hour, इसका 5 units per hour है, 2 units per hour है. And bottleneck, as discussed earlier, that it is the process stage with the smallest throughput rate. Smallest throughput rate means the longest cycle time, the maximum cycle time. So, which task is the bottleneck in this one? So, 3 units per hour, 5 units per hour, and 2 units per hour. सबसे fastest station जो है वो 5 units per hour का है. And the most slowest one is the third one, which is 2 units per hour. So the bottleneck station is this one, 2 units per hour. So the busiest station or the slowest station will be the bottleneck station. So station number 3 in our case is the bottleneck. और जो bottleneck है वही आपके सिस्टम का भी साइकिल टाइम और प्रोडक्शन रेट जो है वो बन जाएगा. So now the capacity of this system will be dependent on this bottleneck station, and whatever is the cycle time or the rate of this bottleneck, that will eventually become the production rate or the throughput rate of the whole system as well. So this is the bottleneck, and what will be the capacity of the process? Capacity, as discussed, that it will be the minimum throughput rate of any of the stages. So if someone asks you that what will be the capacity of this process, so definitely it will be the bottleneck. So 2 units per hour जो है इस system capacity होगी आपकी. And then the throughput time. Throughput time जो है it is the total time of the work unit that it will spend within the system during the production time. So average time that a unit takes to go through the entire processes, including the waiting times, and normally it is measured as a time. And then work in process को calculate करने के लिए फिर आपको ये throughput time जो है उसकी ज़रूरत पड़ेगी. So throughput time normally will be as we say that it is an average time of each unit that it will spend within the system. So that average time will based on the production rate of the system, that what will be the speed of the line basically, and speed of the line is normally the throughput rate or the production rate of the system. So average throughput time अगर आप calculate करना चाहते हैं, so it is equal to the work in process, यानी जितने number of work pieces है within the system, इसको simply divided by आप जो उसका throughput rate है, यानी जो speed है conveyor belt की, उस पर divide करके you will get that average time of each unit. So sometimes if in the question the throughput time is given, the work in process given, so you can directly find the throughput rate of that system. तो ज़रूरी नहीं है कि cycle time available हो. So if the cycle time is available, so you can find the cycle time, and then 1 by cycle time will give you the production rate or the throughput rate. However, if the cycle time is not given and you have the work in process and the throughput time, so you can easily find the throughput rate. Maybe थ्रूपुट रेट अगर आपने फाइंड कर लिया, इफ़ यू हैव द साइकिल टाइम and from that you found the throughput rate, and suppose the throughput time is available to you and it is asked that find the work in process, so then you can easily find the work in process. So one way or the other, uh, जो एंटिटीज़ या जो डिज़ाइन पैरामीटर्स आपके पास अवेलेबल होंगे, so through those parameters you will come up with the final performance measures of the system. So we will explain these steps through a simple example, and this example is of a hammer production process. So there is a system in which hammers are produced. So hammer में आपके पास दो ही parts होते हैं, एक हैंडल होगा और एक जो हैमर हेड बनता है वो है. So suppose this is the graphical representation of that of the whole processes within that system. So at the first step we have machining center, and here we have two machines installed in parallel. The machining station will make the hammer heads, and then they will be sent to the assembly station where the hammer handles will be assembled to the hammer heads, and you will complete the product. Afterwards, that set of hammers will go through to another workstation where it will be packed and then shipped to either to the market or to the storage facility. So तीन वर्क स्टेशंस हैं हमारे पास, मशीनिंग स्टेशन है, असेंबली स्टेशन है और पैकेजिंग स्टेशन है. And in between each workstation we do have the holding facility, the buffer zone. So hammer heads will be produced, they will be stored in the buffer facility available next to machining stations, and from that then it will be delivered to the assembly section and so on. So the work will begin at the machining center, and here we have two lines from the heads of the hammers and place them in a buffer. So हमारे पास यहाँ पे two parallel machines हैं. तो अगर for example इस workstation का cycle time जो है वो 2 minutes है, तो in 2 minutes we will get 2 hammer heads. तो अगर 3 machines आपके पास parallel में होते, so we would then be having 3 hammer heads in 2 minutes. So cycle time जो है that is calculated for a single workstations, and if you have multiple workstations, so simply multiply that cycle time with the number of stations that will be available at that particular locality. So you will come up with the final number of the products or the parts that will be coming out of that particular station. So in 1 unit time we will be getting 2 hammer heads from this station. Handles are then attached at the assembly step, and then finally the finished hammers are sent to the next stage, which is the packaging section, and there they are packed and then shipped. So this is the scenario. So the processing data is also available. Suppose the machining station जो है उसको सेटअप की ज़रूरत पड़ेगी आपके लिए कि यानी जो मशीन पे जो फिक्सचर्स जो फिक्सचरिंग है, जो फिक्सचर डिवाइसेस है वो आपने लगाने होंगे, या जो टूल्स आप यूज़ करेंगे. So the whole setup time of the first workstation is 80 minutes, and then you need 4 minutes to make one hammerhead. So the cycle time of this individual workstation is 4 minute per unit processing. So 4 minute means that after each 4 minute you will be getting two parts, meaning two hammerheads out of this particular station. Suppose the batch size is 200 units and we have identical lines. Identical lines means two identical machines installed in parallel, and simultaneously they will produce the workpieces. The next step is the assembly. Assembly is, let us say, manually operated, and you need two workers to assemble one hammer. And there is no setup time. सेटअप टाइम इसमें नहीं है. मैनुअल वर्कर्स जो है वो यूज़ हो रहे हैं, एंड एक प्रोडक्ट को असेंबल करने के लिए दो वर्कर्स जो है वो चाहिए होंगे. सो ईच हैमर रिक्वायर्स 40 मिनट प्रोसेसिंग टाइम. सो असेंबली टाइम जो है टोटल 40 मिनट्स है. You will need two workers to assemble one hammer. So, and in total we have 34 workers available. So 34 workers mean that in this particular workstation locality we have 17 workstations. तो टोटल 34 है, और एक हैमर को असेंबल करने के लिए दो वर्कर्स जो है वो आपको चाहिए, ठीक है ना. सो 34/2 मीन्स 17 stations will be available at the assembly वर्क स्टेशन. तो यहाँ पे हमारे पास जो है वो we have two workstations. In the assembly we have 16 workstations. So in 40 minutes we will be getting 17 units out of this system. The third section is the packaging, and packaging and shipment section where it needs 30 minutes setup time and 2 minutes for the process. यानी मल्टीपल हैमर जो है वो पैक किए जाने हैं एक पैकेट में, and the total packaging time is 2 minutes. And suppose the lot size जो है वो आपका 100 units है एक पैकेज में, ठीक है ना. सो विद इन वन पैकेज we will pack 100 units, ठीक है ना. सो दिस इज द lot size means the batch size, you know. So you have to take into consideration this batch size while you will calculate the cycle time of this particular system. So first you will have to calculate the cycle times of all the workstations. So cycle time, as I said, that it will be batch time plus the setup time plus the batch size into cycle time of processing time of that particular unit. So this will be 80 plus 200 into 4 divided by 200. यही फार्मूला है जो मैंने आपको इनिशियली बताया था, दिस वन. सो सेटअप टाइम plus batch size into time per unit divided by the batch size. So here the batch size is 200. So 80 plus 200 into 4 divided by 200. So ये आपका 200 मैंने यहाँ पे मेंशन किया हुआ है, ठीक है. So 80 plus 200 into 4 comes out to be 880 divided by batch size से आप डिवाइड करेंगे. So it will be the average cycle time of this station. And it will be minutes per units. And then once you found the cycle time, so then you can easily find the throughput rate of this particular station, which will be inverse of the cycle time. So it is 1 by cycle time. So 880 minutes by 200 units जो है वो cycle time है आपका. इसका रिवर्स जो है वो आपका 200 by 880 ये जाएगा, एंड 0.227 यूनिट्स पर मिनट जो है वो आपका साइकिल टाइम आ गया है फर्स्ट वर्क स्टेशन का. सो इट इज़ यूनिट्स पर मिनट, एंड नॉर्मली द थ्रूपुट रेट इज कैलकुलेटेड एज आवर. So simply multiply it by 60. So you will get units per hour. So throughput rate is inverse of the cycle time. यहाँ पे mention किया हुआ है मैंने. So the overall production rate of a single station of machining center will produce 13.63 units per hour. But if you remember, we have two machines within the system. So it is production rate of a single system, of a single machining center. So in total आपके पास दो machines हैं, तो 13.63 multiplied by 2 आप कर लेंगे and you will get the actual capacity of that system, which is 27.26 units per hour. सेकेंड स्टेप पे आप जाते हैं, असेंबली स्टेप है. तो देयर इज़ नो सेटअप टाइम फॉर द असेंबली स्टेशन and you require 40 minutes to complete one unit. So this means that the cycle time is 1 divided by 40. So the throughput rate will be inverse of that. साइकिल टाइम जो है वो आपका 1 यूनिट पर यानी 40 मिनट्स पर यूनिट है, तो उसको यूनिट पर मिनट अगर आप करेंगे सो यानी इट विल बी इनवर्स ऑफ द साइकिल टाइम. सो यू विल बी हैविंग 1 यूनिट डिवाइडेड बाय 40 मिनट्स. सो इन टोटल आपके पास आ रहे हैं 0.025 यूनिट्स पर मिनट. आवर्स में आप कन्वर्ट कर दें, सो इट कम्स आउट टू बी 1.5 यूनिट्स पर आवर फॉर अ सिंगल स्टेशन. लेकिन यहाँ पे हमारे पास 34 वर्कर्स हैं, सो वी हैव 34 वर्कर्स अवेलेबल एंड यू नीड 2 वर्कर्स फॉर वन असेंबली. सो इन टोटल वी हैव 16 वर्क स्टेशन एट दिस पार्ट. सो 1.5 multiplied by 17 will give you the total output rate of the assembly station. So here it is 25.5 units per hour. And similarly जो लास्ट स्टेप है आपका वो भी मशीनिंग की तरह ही है, क्योंकि वहाँ पे आपके पास सेटअप टाइम है. सो यू विल इंक्लूड दैट सेटअप टाइम. सो 30 is the setup time, batch size is 100, and if you multiply it by the cycle time और उसको फिर फुल बैच टाइम पे जो कि 100 यूनिट्स आपके पास बैच साइज, so it will give you the average cycle time of the packaging section. So 230 by 100 minutes per units. ये cycle time है. यानी अगर आप यानी डिवीजन करते हैं तो दिस मीन्स दैट 0 कैंसिल हो जाएगा. सो 23 by 10 is 2.3 minutes per unit आपके पास cycle time है. And the throughput rate will be 1 divided by 2.3 then. Or you can say 100 by 230. So rate means the throughput rate of the packaging section is 0.43 units per minute converted to hours. So it comes out to be 26.09. So you have found the cycle time of each workstation, and then based on those cycle times you have then found the throughput rates or production rates of each workstation, and now you can decide for the system that what will be the capacity of the system and what will be the overall cycle time of that system. So overall अगर आप इसको जो सारे परफॉर्मेंस मेजर्स हैं वो आप एनालाइज करें, कंपेयर करें. सो प्रोसेसिंग स्टेप्स जो है वो 3 है हमारे पास. मशीनिंग सेक्शन है, असेंबली और पैकेजिंग. कैपेसिटी हर एक स्टेप की अगर आप देखें तो थ्रूपुट रेट्स मशीनिंग की जो है वो 27.26 है, असेंबली की 25.50 है, सिमिलरली फॉर द पैकेजिंग. सो नाउ व्हाट विल बी द कैपेसिटी ऑफ द होल सिस्टम. ये तो इंडिविजुअल थी, तो होल सिस्टम की कैपेसिटी जो है वो मैंने आपको बताया था कि इट विल डिपेंड अपॉन द बॉटलनेक स्टेशन. इनमें बॉटल नेक स्टेशन आपका कौन सा है? बॉटल नेक स्टेशन विल बी द slowest workstation, having the maximum of the cycle time. And if you have the maximum cycle time, this means that that particular station will have the lowest production rate or throughput rate. So इसमें सबसे slowest station जो है आपका वो assembly workstation है. So this is the bottleneck workstation, and the production rate or the capacity of the whole system will be 25.50. So assembly is the bottleneck. So here are some of the formulas that you can use. They are just for your reference. ऑपरेशन टाइम अगर आपने फाइंड करना हो तो ऑपरेशन टाइम जो है मशीन का, किसी भी मशीन टाइम का, उसका जो सेटअप टाइम है डिवाइडेड बाय रन टाइम, so it will give you the operation time. Throughput time, as I said, it is the average time for a unit to move through the system. एंड नॉर्मली उस वेलोसिटी को जो आप देखते हैं या स्पीड को जब आप देखते हैं एक सिस्टम की, यानी जो रेट है, जो प्रोडक्शन रेट है, तो इट इज़ बेसिकली द थ्रूपुट टाइम डिवाइडेड बाय जो आपका वैल्यू एडेड टाइम होता है, यानी जो ऑपरेशनल टाइम होता है. साइकिल टाइम जो है इट इज़ द एवरेज टाइम बिटवीन कंप्लीशन ऑफ यूनिट्स. सो थ्रूपुट रेट जो है वो फिर आपका साइकिल टाइम पे डिपेंडेंट है. इट इज़ इनवर्स ऑफ द साइकिल टाइम. एफिशिएंसी अगर आपने फाइंड करनी हो तो एफिशिएंसी इज़ बेसिकली आउटपुट बाय इनपुट, और आउटपुट बाय इनपुट जो आपका जो लाइन बैलेंसिंग वाला प्रॉब्लम अगर आपको याद हो, तो वी हैव एन एक्चुअल आउटपुट ऑफ द सिस्टम एंड वी हैव स्टैंडर्ड आउटपुट विच इज़ अ थ्योरेटिकल वन. सो वो आपका आउटपुट होगा, और इनपुट जो है वो आपका जो स्टैंडर्ड जो थ्योरेटिकली आपने फाइंड किया था वो आपका इनपुट बन जाएगा. सो एक्चुअल आउटपुट डिवाइडेड बाय स्टैंडर्ड आउटपुट विल गिव यू द एफिशिएंसी ऑफ दैट सिस्टम. एफिशिएंसी को हम प्रोडक्टिविटी भी कहते हैं. सो प्रोडक्टिविटी यही है, एक्चुअल आउटपुट बाय स्टैंडर्ड आउटपुट. सो ओवरऑल जो एफिशिएंसी या प्रोडक्टिविटी आपने फाइंड करनी हो तो उसमें आपने आउटपुट एंटिटी को देखना होगा और इनपुट एंटिटी को देखना होगा. यूटिलाइजेशन फिर हमने फाइंड की थी उसमें. सो यूटिलाइजेशन इज़ बेसिकली आपके पास यानी जो एक एक्टिवेटेड टाइम होगा, यानी फॉर विच यू विल activate the machine and it will perform the processing activity, and divided by the total available time. सो टाइम अवेलेबिलिटी आपके पास साइकिल टाइम की होगी, यानी फॉर एग्जांपल 1 मिनट है तो 1 मिनट में आपका मशीन जो है वो कितना यूटिलाइज हो रहा है, कम एग्जैक्टली 1 मिनट के लिए यूटिलाइज हो रहा है, या 30 सेकेंड्स के लिए हो रहा है, या 40 सेकेंड्स के लिए हो रहा है. So the actual activated time divided by the total available time will give you the utilization of that particular workstation. So for example, if you have 1 minute time available time, and if you are operating the equipment for complete 1 minute, so this means that utilization will be 100%. So the time of activation of any machine is basically the flow rate, and the अवेलेबल टाइम इज़ द कैपेसिटी ऑफ दैट मशीन, कि उसकी फुल कैपेसिटी कितनी है. थ्रूपुट टाइम वही है, वर्क इन प्रोसेस इनटू साइकिल टाइम, या वर्क इन प्रोसेस अगर आपने फाइंड करना हो तो दैट इज़ थ्रूपुट टाइम डिवाइडेड बाय द साइकिल टाइम. वर्क इन प्रोसेस जो है अगर साइकिल टाइम नहीं गिवन तो इट विल बी थ्रूपुट टाइम इनटू थ्रूपुट रेट. 1/साइकिल टाइम जो है वो थ्रूपुट रेट ही है बेसिकली आपका. सो ओवरऑल अगर आपके पास लेट अस से if you have the work in process and if you have the flow time, so flow time means the throughput time, so you can then find the capacity of the system from that also. So these are different parameters that you can use for finding the performance measures of the manufacturing systems, and that's it. CNC जो है वो इंशाल्लाह हम नेक्स्ट वीडियो में डिस्कस करेंगे.